Hello students, now I am going to explain about the type 2 problems in a complex variable 1 in a module 1 in the subject complex analysis, probability and statistical methods. So before going to start the problems doing under this type 2, first we should know the working rule of this type 2. Construction of analytic function when real or imaginary part is given. This is what the type 2 problems. So in a first stage, suppose in a given question real part or imaginary part they given in terms of x and y, means first we have to find out the partial derivatives with respect to x and y. It means ux uy, or the imaginary part v they given, means we have to find out vx and then vy, and consider the formula f dash of z which is equals to ux plus I into vx. Given u or v as a function of r and theta, means you just find out u or u theta or v or v theta. You just consider the formula f dash of z which is equals to e to the power minus I theta u r plus I into v r. In the next step, if given u, suppose in a question real part is given, means you just then you just replace vx as minus uy. Suppose real part they given, means you just replace vr as minus 1 by r u theta with the help of the CR equation. That changes you have to do here. Similarly, if imaginary part is they given, means you just replace ux as vy or ur as 1 by r into v theta with the help of CR equations. After this, you just put x equals to z and y equals to 0 in a Cartesian form, and r equals to z and theta equals to 0 in polar form. You just integrating with respect to z, and then you will get the value of f of z in terms of z only you will get. This is what the procedures we have to follow in a type 2 problems. Now we'll do few problems based on this type 2. We'll see the first problem. Find the analytic function whose real part is u is equals to log of square root of x square plus y square. Okay, here they asked us to find out the analytic function. It means f of z we have to find out, and the given data is u they given. So the given u function you should write first, that is u is equals to log of square root of x square plus y square. We can write that as log of x square plus y square, that whole to the power 1 by 2. We can write that as u is equals to 1 by 2 into log of x square plus y square. So already I told you, first we have to find out partial derivatives, that is ux and uy we have to find out. So ux is 1 by 2 into 1 by x square plus y square, that into 2x. Here 2 will get cancelled. We are getting ux as x divided by x square plus y square, and uy is y divided by x square plus y square. Already we know that f dash of z is nothing but ux plus I into vx. With the help of CR equation, here we know the value of only ux and vy. Ux and uy, that two value we know. But in a formula vx is there. You just convert that v in terms of u with the help of CR equations. That is vx equals to minus uy. You just do changes in that formula. So formula will become f dash of z which is equals to ux minus I into uy. In a next step, you just substitute the value of ux and also uy in terms of x and y. That values you just substitute. Next, you just put x equals to z and y equals to 0 in a previous equation, so that f dash of z reduces to z divided by z square plus 0 minus I, that into 0. So second term it is completely vanished. So the after simplification we are getting f dash of z is 1 by z. On integration with respect to z we have to do, so that this f dash of z will become f of z. Integration of 1 by z with respect to z will become log z plus some integral constant. Take that integral constant as c. This is what our required solution. Now we'll see the next problem. Determine the analytic function whose real part is sine 2x divided by cos hyperbolic of 2y minus cos 2x, and also find the imaginary part. So in this question they asked us to find out f of z, and the given data is u value they given. So they asked us to find out even v value also they asked us to find out. Okay, first u, the given u you just write, that is sin 2x divided by cos hyperbolic of 2y minus cos 2x. So now we'll find out the partial derivatives, that is ux equals to 2 into cos 2x, that into cos hyperbolic of 2y minus cos 2x minus sin 2x into 2 into sin 2x, that divided by cos hyperbolic of 2y minus cos 2x, that whole square, and uy will become 0 into cos hyperbolic of 2y minus cos 2x minus sin 2x into 2 into sin hyperbolic of 2y, that divided by cos hyperbolic of 2y minus cos 2x, that whole square. So now we got the values of ux and then uy. Now substitute this in a formula. So formula is f dash of z is equals to ux plus I into vx. So here we know the value of ux and then uy, but in a formula vx is there. Convert that vx in terms of u with the help of CR equation, that is vx can be written as minus uy. So the formula reduces to f dash of z equals to ux minus I into uy. Let f dash of z, so that formula is reduced in that form. You just substitute the value of ux and then uy. So f dash of z will become 2 into cos 2x, that into cos hyperbolic of 2y minus cos 2x minus 2 into sin square 2x, that divided by cos hyperbolic of 2y minus cos 2x whole square, plus I into 2 sin 2x sin hyperbolic of 2y divided by cos hyperbolic of 2y minus cos 2x, that whole square. In this equation you just put x equals to z and y equals to 0. So f dash of z can be written as 2 cos 2z 1 minus cos 2z minus 2 sin square 2z, that divided by 1 minus cos 2z, that whole square, plus I into 0. The imaginary part, it will completely, it will vanish. So we have to do simplification only the real part. So 2 into cos 2z minus 2 cos square 2z minus 2 sin square 2z divided by 1 minus cos 2z, that whole square. In a numerator, if you taken minus 2 as common, means that will become cos square 2z plus sin square 2z. The value of that is 1. So this equation can be written as 2 cos 2z minus 2, that divided by 1 minus cos 2z whole square, which is equals to minus 2, 1 minus cos 2z divided by 1 minus cos 2z whole square. I think one term will get cancelled. So minus 2 divided by 1 minus cos 2z. 1 minus cos 2z can be written as sin square z. So minus 2, let it be as it is, sin square z can be written as 2 into, so that 1 by sin square can be written as cosecant square. So here 2 will get cancelled, so that this can be written as f dash of z will become minus cosecant square z. So this is the value of the derivative f dash of z, but we need f of z. You just go for integration is with respect to z. So integration differentiation will get cancelled. That equation will become f of z, which is equals to integration of minus cosecant square z with respect to z plus some integral constant, take that as c. So f of z will become cot z plus c. This is what our required analytic function. So still question is not completed because they asked us to find out the imaginary part. So f of z we got it as cot z. Cot can be written as cot of x plus iy because the value of z is x plus iy. Cot is cos by sin. You just multiply and divided by sin of x minus iy, both numerator and denominator. We can use that formula. So you just that cos a into sin b and then sin a into sin b. With the help of that formula, we can simplify this. After simplification, we can write this as u plus iv. F of z is nothing but u plus iv. That can be written as sin 2x plus I into sin hyperbolic of 2y divided by cos hyperbolic of 2y minus cos 2x. You just compare the real part and then imaginary part. So that will become u is equals to sine 2x divided by cos hyperbolic of 2y minus cos 2x. That already they given in the question. We need imaginary part, that is v value. So that will become sine hyperbolic of 2y that divided by cos hyperbolic of 2y minus cos 2x. This is what our required solution. Now we'll see the next problem. Construct the analytic function whose real part is r square into cos 2 theta. Clearly they given real part. So first you find out ur and then u theta. Ur is 2r cos 2 theta and u theta is minus 2r square sin 2 theta. So in a polar form, f dash of z formula is e to the power minus I theta ur plus I into vr. So here you just convert that vr in terms of ur. So it means vr can be written as minus 1 by r into u theta. Substitute that in a previous formula. So after substituting the value of ur u theta, you just put r equals to z and theta equals to 0. So f dash of z, that equation will become 2z. You just do the integration so that f of z will become z square plus some integral constant. That is what our required value. Thank you.